Hello, this is a brief presentation on weights and complex survey designs. For today, we'll be introducing complex survey designs, discussing the concept of weights, and then discussing how AM software may be utilized to apply weights in these complex survey designs. So, where are complex survey designs? Pretty much all big federally funded data sets consist of complex survey designs, and this is mainly because simple random samples are not either feasible, either logistically speaking or financially. So what I mean by logistically, it would be difficult to find a sampling frame for all individuals in the US and do a simple random sample of them. Financially, it would be very expensive to do this also. So complex survey designs come into play, and that they provide an approach where you can stratify the population according to census data, whatever the last census was, and you can stratify the population and use clusters of the population from which to randomly select individuals who will represent the population as a whole. And we do this to estimate trends in the population accurately, so that the sample isn't skewed toward one population or another. That's not skewed to rural versus urban or urban over rural, and that there's an accurate representation of the population based upon the data. So where do you find this data? The National Center for Education Statistics, which is nces.ed.gov, and another good source for general population data is the census website also. But for education data, you'll probably want to go to the NCES website. Let's go there quickly. So, National Center for Education Statistics. To find data on this website, just go Publications and Products, and then go down to Products, and it'll say Data Products the last 6 months. You can just select that. You can extend it out and go way beyond that. You can go 10 years back if you want and get data, but after about 10 years, the data starts to lose its relevancy. So, relevance, sorry. And but here are some data sets that are available within the past, like this, the high school longitudinal study of 2009. The first follow-up public use data came out on November 13th. And so you can find data that will be applicable to you. Most notably, there's also a bunch of different data sets, but most notably there's also like TIMS, which is Trends in International Math and Science Study, and the ECLSK, which is the Early Childhood Longitudinal Study, which is also used a lot. And then also PEQIS, which is the Post-Secondary Quick Information System. We shouldn't forget the Census Bureau. There's lots of data there. If you go census.gov and then select data, and you can find all sorts of data sources there that may be applicable to you. So, going back to the PowerPoint, those are two sources of data, but there are many more out there. But if you're in education, National Center for Education Statistics would be the best one. So, what is a weight? Weights are basically, in the most basic form, the inverse of the probability of selection. So 1 over P, which is probability. And why do we use weights? What's the point of it? Well, the point is to equal out or adjust for the unequal probability of selection of an individual. So let's say, I'm just going to make up a hypothetical scenario. Well, it's not too hypothetical. It's based on some reality. Let's make it really basic. There are probably roughly 50% women and 50% men in the United States. So, with that said, if I were to sample from the population of, let's say I get a sample of 100 Americans, and I end up in my sample having 70 women. And so I'm saying that the sample is 70% women, but that's not an accurate reflection of the population. So I have to adjust for that by creating a weight. And that weight would mean that I would weight the value of men's responses a bit more than the women's responses so that they would equal out. So the whole point of weights is to adjust for the unequal probability of selection in a sample so that it represents the population. And you get your population numbers, the idea that there's 50% men from 50% women, from the census data. You would know that from that, or just logic in the case of gender. But for different populations, you would find out, oh, there's this percent of this population across the United States, and I'm either oversampling for them or undersampling from them based upon my sample, and I need to adjust for that unequal probability of selection. So that's the whole point of a weight, is to adjust your sample characteristics so that they represent the population as closely as possible. So, using some weights and real data, this is data from the SEALS. I think I have that website open. Yeah, the SEALS, which is a special education elementary longitudinal study for the cohort of elementary school age students receiving special education services from 2000 to 2006. And from that data, you have a weight variable, and you'll find out from the documentation from whatever data set you're using, it will explicitly tell you the appropriate weight to use. And so it will tell you this is the weight variable. And you'll have a strata variable, which is the stratification variable for the sample, and then the PSU, or cluster variable. PSU is also known as the primary sampling unit. It's also known as the cluster variable. And then from that, you also have the replicate weights in the sample data sets. The replicate weights you may or may not use in the software that you are applying the weights. It kind of depends on the software. The one we're going to be talking about is freeware. It's called AM, and it does use replicate weights. So we'll look at that real quick. So what does the AM software look like? I have a website for that. The AM software is a free software you can download from, I think it's AIR. Yeah, the AIR website. That you can download. All you have to do is, American Institutes for Research. All you have to do to download it is register a username, and it'll let you, and password, of course, account basically, and you can download the software. And I recommend it if this is your first foray into weights, because it's freeware for one, and also it's a graphical user interface, so you won't have to be writing a lot of code for your first attempt to apply weights. So, going back to the PowerPoint, what does it look like? Basically, you identify the weight by right-clicking a variable and selecting Edit Metadata. Then you select the appropriate design role for that variable. You're saying that this is this variable is involved in the design of the data set, and you just select weight as such. And then you repeat the step for the strata and the cluster variable. You identify each variable as a strata or a cluster variable, and you just select OK. And it's a pretty easy approach based upon AM, and then you just go on and do your analyses, in which it's a graphical user interface, so it's not that difficult. So please contact me if you have any other questions about weights or how to apply them, especially as you first start getting your feet wet into weights, if you so choose to get yourself deeper into complex survey design data. And good luck.